Hi everyone, in this video we're going to continue on with the 3A practice questions. So this is the part 2 of our video on 3A. So if you haven't watched part 1, might be a good idea to do that before we go on with the questions. Alright, in the previous video we did look at the hyperbola. So now we're going to look at the square root graph. So this function here, y equals the square root of x minus 2. So you do need to eventually look at an equation and understand what the transformations are. So I've highlighted here the minus 2. That just means we've shifted to the right 2. Okay, so our square root graph has been shifted to the right 2. Now, when thinking about the square root graph, I might just do a quick sketch over here. All right, so sorry, I got a bit distracted there. Your square root graph starts at 0 and goes like that. So this is y equals just the square root of x. So if you think about shifting to the right 2, this graph is just going to be shifting along by 2, and so it's moved across 2, and your endpoint is going from 0, 0 to 2, 0. All right, so that's just a rough sketch in your head, but we're going to do a proper one in a second. Okay, so it's a square root graph. I'm going to write that here. So square root graph that has gone to the right 2. All right, so your endpoint for a square root graph is at 0, 0. So it is including 0 because you can take the square root of 0, but we're not taking the square root of a negative number. Okay, so we're only looking at real solutions, not imaginary solutions. So x does have to be 0 or more than 0. Okay, so it's shifted across 2. So our endpoint is now here. And when sketching it, it's probably a good idea, especially when you've got a scale, to draw it accurately. So because we've got a square root graph, it's probably a good idea to have under this radical, under your square root sign, a perfect square. So if I let x equal 6, for example, y is going to equal the square root of 6 minus 2, which is the square root of 4, which is 2. So another point on this graph is 6, 2. So there's 6 and there's 2. And that's just going to help guide you, because you just don't want to go like something like that. Probably should keep going. And it's not going through the right points, especially because we've got a scale there. So let's make sure our scale is correct. And the next one, if I was to let x equal 11, we would have 11, 3. So we don't want to go above the 3. So it's going to go something like that. So what I was saying before, if we're looking for the shape of our graph, just make sure that you try to find another point just to help guide you. And I probably should have done the same thing with my hyperbola, but usually when we're sketching, we don't have such an accurate scale. Okay, so I've sketched my graph. Remember, we have to put on any asymptotes. There's no asymptotes for a square root graph. Axis intercept, so there is this one here at 2, 0, so I'll put that on. And then we've got to do our domain and range. So your domain and then the range. All right, so your domain, we're starting at 2, and it includes 2. And we've got to go to infinity. It's a terrible infinity. Okay, so remember, if we weren't graphing it, we also should have a look at our equation. So we can't take the square root of a number less than 0 or a negative number. So x minus 2 has to be greater than or equal to 0. So that means x has to be greater than or equal to 2. Your range, as you can see on the graph, goes from 0 to infinity, so it is also included. All right, so domain and range. Okay, let's move on to the next one. So here we've got a truncus, and it's been shifted down 3. So it's a truncus that's gone down 3. All right, so with the truncus, we do have asymptotes. So on a basic truncus, so 1 over x squared, it would be at our axis intercepts. But because we're shifted down, what was it, 3, our horizontal asymptote is now going through -3. Excuse me. And we're going to stick with the vertical one. That's through x equals 0. All right, there's been no reflections. So our truncus is still going to be positive, like this. But I do need to find my x-intercept. So I'm going to have 2 x-intercepts. So let y equal 0. So we've got 1 over x squared equals 3. So then we're going to have x squared equals 1 over 3. So x equals plus or minus 1/3. Oops, square root 1/3. So very, very close to Just trying to draw this as accurately as possible because it's very, it's probably not that accurate. Actually, all right, I just did 1 over the square root of 3 on my calculator, and it is around 1/2, so I probably was fine where I was. It's really hard to see this scale though. Oh, do it again. All right, I'm going to put my points down. So we're going to go through there and there. Yeah, I didn't really choose the best grid, did I? Yeah, oh gosh. That is a terrible truncus. Oh my gosh. All right, I'm just going to give it another go. This is really hard to do on the computer. Oh, that's a bit better. Can we do a straight line? Okay, it's not the best, but hopefully you're doing it by hand, not on the computer screen, would be a little bit easier. Okay, so we've found the x and y intercepts, so I need to put them on. So that's at 1 over root 3, or we probably should rationalise the denominator, but I'm going to leave it like that for now. And -1 on root 3, 0. Labelled our asymptotes, remember our checklist, so just making sure we cover everything. So we've sketched, we put our asymptotes on, axis intercepts, and now all we need to do is our domain and range. Whoops, wrong question. All right, so our domain and range. Okay, so our domain, we're any real value excluding 0. And our range goes from -3, but not including -3, to infinity. All right, moving on to some other questions. So for each of the following, state the transformation which maps the graph of y equals f of x to the graph of y equals f1x. Okay, so we've got first of all, a square graph, a parabola. What am I saying? A square graph, a parabola, and it's undergone this transformation here. So the +5, so that means it has gone 5 units in the negative x-axis. Probably not the best phrasing. But for question B, we've got hyperbola. So this first one, we've got a hyperbola, I can see, and it's been shifted to the right 3, but it's got to go back to 1 over x. Okay, so we're not starting with the basic one and going to a transformed one. We're starting with a transformed one and we're going back. So if I've shifted to the right here, that means to get back, I need to go to the left. So 3 units in the negative x-axis. I'm copying what I wrote above. Can't even spell x. Is. All right, so you do need to be able to look at an equation and think about, well, where are the transformations? All right, question 2. This time we're being given an equation and the transformation. So I can see this just means it's gone to the left 3 units and up 2. Okay, so you can be given a function that isn't the basic function. So we've got a parabola here, but it's not the basic one, which is y equals x squared. It's already undertaken some transformations, and then it's going under it more transformations. So this original parabola, I can see that the features of it has a turning point at 2, 3, which means it has gone to the right 2 and up 3. But what we're going to do now is move it to the left 3, and we're going to move it up 2. Now, when we're doing that, remember the mapping we did in the previous video? So we're going to have, I'm just going to be consistent with my notes. X dash is equal to x minus 3. Okay, so our new point. And then we've just got to rearrange it. Okay, so just to make x and y the subject. And then we can substitute it into our original equation. So instead of having y, I'm going to have y dash minus 2. And instead of x, I'm going to have x dash plus 3. So just substituting them in. And then I can just complete the rest of the equation. So I still put that minus 2 in, squared plus 3. All right, you can drop the dashes on your x and y. So x plus 3 minus 2, so it's going to be x plus 1, squared, and then plus 3. Oops, what am I doing? Oh no, sorry. I knew it had changed, but I hadn't done that yet. Okay, so all I've done is just brought my like terms together in that previous one, and now I'm just going to add 2 to both sides just to get y by itself on the left-hand side. So we're going to have y equals x plus 1 squared plus 5. So what has happened to y equals x squared? Initially, it has gone to the left 2 and up 3. And then we're going, so if we look at just maybe the turning point, which was, oops, I'm going to go out of my screen. Let me just move the thing across a bit. Can I do that? No, wrong way. Whoops. Oh gosh. There we go. So think of the turning point. So the turning point of the parabola is 0, 0. When I shifted to the right 2, my point now, and up 3, it becomes 2, 3. And then I went under some more transformations. So then I went to the left 3 and I went up 2. So my turning point now becomes 2 minus 3 is -1. And 3 plus 2 is 5. And you can kind of see we do have it in turning point form. So you can see the -1 and the 5. Do I need to do anything else? No, I'm not going to write the domain and range. All right, so for the next one, we do exactly the same thing. So let's have a look at our transformed x. So it becomes x minus 1. Oh, sorry, big truck just going past. And just rearrange. and then we substitute it back into our equation. So y dash minus 1 equals, then x, we're going to have x dash plus 1 plus 2 all cubed, so it's a cubic this time. All right, leave the 1. I'm going to take, leave the y. I'm going to add 1 to both sides. And then we've got x plus 3 cubed plus 2. All right, and when you think about it, our graph has gone to the left 1, so it was already to the left by 2. Now it's gone and to the left by another 1, so that's why we end up with 3. And this point here, the 1, it's already been shifted up 1, and it shifts up by another 1 to become 2. All right, I think that's it for this video. I'll stop there. All right, bye.